question asks us to calculate the equilibrium constant for a particular reaction given a delta G value. It also asks us to calculate the percent of A and percent of B at equilibrium. To do so, we'll need our equation for delta G. Delta G equals negative RT ln KEQ. Let's go ahead and plug these numbers in and see what we get. Delta G is given to us in the problem. It's negative 1.8 kcal per mole. And that's equal to negative, R is a constant. In kilocalories, it's 0.01987 kcal per mole Kelvin. Temperature is given to us in the problem. It's 298 Kelvin. And we're solving for KEQ. When we multiply R and T together and divide that into negative 1.8, we get a value for the lateral log of KEQ to 2 sig figs of 3.0. Solving for KEQ then, KEQ equals 20. From here, we can calculate the percent of A and B. A KEQ of 20 means there's 20 parts of B for every 1 part of A. So we can use that formula, or that ratio, to help us figure out the percent of each. We can say that the percent of B is equal to the 20 parts of A, or the 20 parts of B in 21 parts total. If there's 20 parts B, 1 part A, there's 21 parts total, and 20 of those 21 parts are B. So that tells us that our percent of B is 95%, which means then subtracting from 100, that our percent of A is 5%.